Hello, this is Eureka Math Module 1, Lesson 1. It's the very first video for this school year. So when you start a video, what you're going to do is the first thing you're going to do is write down this essential question. Pause it so that way you have plenty of time to write it down, and then we'll go ahead and continue. Okay, how is finding an associated rate or unit rate helpful when making comparisons between quantities? So this lesson is all about relationships as measuring rate. So we see rate in a lot of different things, and what we're going to talk first today is how fast we can pass papers out. So you might see someone be able to pass papers out really fast. You might see someone taking their time. We're going to go ahead and talk about the ratio from the papers passed to the amount of time that it takes. So in our first trial, we're going to write 60 papers in 60 seconds. So if you're thinking that's 1, 2, 3, so someone's passing out 1 paper per second. Okay, so what is the ratio then? The ratio of the number of papers passed, ratios are in order, so number of papers passed to time. So the number of papers passed has to go first, which is 60, and then the time has to go second, which also happens to be 60. Okay, so that means that there is 1 paper per second, which the unit rate would be 1. Okay, that one was pretty easy. Let's go ahead and look at trial number 2. What if I could pass the papers out faster? What if I still had 60 papers, but it only took me 45 seconds to pass it out? Okay, maybe I'm trying to beat some sort of a record or a race or something like that. That ratio would be 60 papers to 45 seconds. Remember, the time goes second. Okay, now this one isn't as easy to do. You can reduce the ratio. If you reduce 60 and 45, you'll get the number 15 goes into both of those, so you would get 4 to 3. Okay, so write this small, 4 papers in 3 seconds, but that doesn't really help us compare it to the first one. So we can do 4 thirds, which equals 1.3 repeating, and that would be papers per second. It's okay that it goes out of the box a little bit. So 1.3 papers per second. What would be better if you were racing and you were trying to do it the fastest? Would it be faster to do 1 paper per second or 1.3 papers per second? You kind of have to think about it. It's 1 second, so that's the part that stays the same. In the second scenario, I can pass out more than 1 paper per second. Not 2 papers, but more than 1. Okay, so the unit rate here is 1.3 repeating, which is the same as 4 thirds. You can write it as either way. They're the same number. Okay, and 4 thirds is 4 divided by 3. So if you type that in your calculator, you'll get 1.3 repeating. Okay, in the last one, I'm still going to pass out 60 papers, but it only takes me 30 seconds. If it only takes me 30 seconds, it's going to be a much easier conversion. This would be 60 to 30, which is actually equals 2 to 1, which means 2 papers per second. And that would be a unit rate of 2. Okay, so in the first example, we could pass out 1 paper per second. In the second example, it was 1.3 repeating papers per second. And in the last example or trial, it was 2 papers per second. Okay, so this one was the fastest. So it's just showing you that you can compare 2 quantities. Okay, we're now going to talk real quick about some of the key terms that we're going to see. You're going to actually want to pause this and copy these down. Okay, so a ratio I have here in orange, it's an ordered pair of non-negative numbers which are both not 0. So basically it's 2 positive numbers. The ratio is identified as A to B to indicate the order of the numbers. The number A is first and the number B is second. Okay, of course A and B aren't numbers, but they stand for it. So it could look like this, 3 to 2, 5 to 1, or it can be 4 to 10. So they can be reduced ratios or not. Okay, a rate is a ratio of two quantities such as 5 miles per 2 hours, and it can be written as another quantity called a rate. So the rate of two quantities can be written as another quantity called a rate. So 5 miles per 2 hours. Now, that wouldn't be driving. What would that be? If you went 5 miles in 2 hours, I would say that you would just be walking, okay? And if you divide 5 divided by 2, that's the same as saying 5 divided by 2 like this. So if you take your calculator out, type in 5 divided by 2, and you'll get 2.5. So it's 2.5 miles per hour. So that might be how fast you're going if you're going for a walk. Okay, and then the unit rate is actually very similar. It's saying the rate per one. So right here, this is the rate for 1 hour. Many, many, many times we see unit rate with money, okay? So let's go ahead and underline that. Often used with money. Okay, so the unit rate tells the number of units of one quantity per 1 unit of a second quantity, which sounds confusing, but really what it's saying is the price 0.4 means one juice box costs 40 cents. So if you're ever at the store and you see like, you know, a 6-pack of Pepsi or something, you can divide the price by the number of cans or bottles, and then you would get the price of 1. Okay? So if a 6-pack of juice costs $2.40 for 6, then it would be 40 cents per juice box. Okay, these terms should be a little familiar. I know the wording is a little proper, but really ratio is the comparison of two numbers, just like how we wrote it here. And then the unit rate is the other one I want you to pay special attention to. That's the price per one, or how far you can go in 1 hour. Okay, and then down below, we're going to talk real quick about equivalent ratios. So when we think back to that original example with the papers, those are not equivalent ratios. Just like we would say 60 to 60 is not equal to 60 to 45, and it's not equal to 60 to 30. Those are not equivalent. And it's easy to see that because the first number is 60 and the second numbers are all different. Or you could say 60 over 60 equals 1. 60 over 45, we got, remember when we divided that, it was 1.3 repeating. And then 60 over 30 is 2. So obviously they're not the same. They would have to be the same every time you divide it. So anytime you do the papers divided by the rate, it would have to be the same. Now, what if we did a trial and it was we said, okay, let's have this person here, whoever passed these papers out, let's have them pass out 30 papers and see how long it takes. And if it only took them 15 seconds, then 30 over 15 is 2. So therefore, those are equivalent ratios. So 30 to 15 and 60 to 30, those are equivalent ratios. So there can be equivalent ratios. You'll get the same thing when you divide the numbers. Okay, so that's just a brief introduction on ratios, rates, and what they are. We're going to do one more example together that has to do with class sizes. So in class number 1, let's imagine that there are 12 boys and 8 girls. Go ahead and write that ratio. Use that colon, you know, the 2 dots. Go ahead and write 12 to 8. And now go ahead and reduce that. A lot of kids see that those are both even numbers, so they say, oh great, that's 6 to 4. And that's true, except those are even again, so it would reduce one more time to whole numbers 3 to 2. If you know your multiplication facts, you know that 4 goes into both of those, so you could have actually divided those both by 4 and gotten 3 to 2 right at the beginning. Okay, so there's your final reduced ratio for class 1. Let's take a look at class 2. This one says 16 to 10. Go ahead and reduce 16 to 10. Did you get 8 to 5? And then can that be reduced? No, it cannot, so we would leave it like that. Okay, now I'm going to show you classes 3, 4, and 5. I want you to go ahead and try to reduce those ratios as best as possible. I'll give you a hint. One of them cannot be reduced. One of them cannot be reduced. Okay, pause and try on your own. Okay, if you are listening to me right now, hopefully that means that you have something filled in for all of those other classes. Do you have something filled in here? If not, pause it and try it on your own. There's no harm in it. There can only be good things that happen from you trying it on your own. Okay, did you write 14 to 10? And did you know that that was equivalent to 7 to 5? Class 4, it cannot be reduced. 11 to 12 is already reduced as far as it can be, okay, to keep it as whole numbers. And then for class 5, it would be 15 to 15, which is 1 to 1. So for every one boy, there is one girl. In the other classes, for every 11 boys, there were 12 girls, or for every 7 boys, there were 5 girls, and so on. So you can look and see the patterns, okay? Like which ones are closer as far as equivalent ratios. However, none of them are exactly equivalent. Okay, how about the whole 7th grade? How many boys are there total? How many girls are there total? If you want, you can pause it and add them all up. Okay, did you get 70 and 55? How can you tell by looking at those numbers that it does reduce? If you know your math facts or your divisibility rules, you know that it ends in a 0 and a 5, and therefore 5 can go into both of those. So this one reduces to 14 when I divide by 5, and this one reduces to 11. So 14 to 11 is the whole class, the whole 7th grade class. So there are more boys than girls, and that was true in class 1, class 2, class 3. Class 4, though, had less boys than girls, and then class 5 was an even split. So it's kind of interesting to see how that all works out. Okay, and then how can you tell ratios are not equivalent? We know that 12/8 is not equivalent to 16/10 because when we reduce them, we got 3 to 2 and 5 to 5/8. So when you reduce, or sorry, 8 to 5. When you reduce them, you will get the same thing if they are equivalent ratios. Okay, so again, I'll go ahead and box all those in red so you can see. 3 to 2 is not the same as 8 to 5. It's not the same as 7 to 5. Not the same as 11 to 12. Not the same as 1 to 1. Okay, and then none of those were equal to 14 to 11. So these are all ratios. They are not equivalent. Okay, we're going to talk about another time that you see rates, and you might want to ask your parents about this if they've ever seen something like this. It says that Value Mart is advertising back to school sale on pencils. 30 sells for $7.97 and a 12-pack sells for $4.77. So we're going to try to figure out what the rate is and then which one is the better deal. Okay, if you see here that the pack of 30, it's $7.97 for 30 pencils, and the pack of 12 is $4.77 for 12 pencils. Okay, we're going to go ahead and divide those. So go ahead and divide the order that they're in. When we're finding rates or unit rates, we're going to do price divided by quantity. Okay, or you can say it like this, price divided by quantity. You have to divide in that order. Okay, when you divided, you probably got something long and decimals. Pause this and try this on your own. Okay, the pack of 30, when I divided $7.97 by 30, I get about 27 cents for one pencil. The pack of 12 is about 40 cents per pencil. That's actually a pretty big difference when you're talking about one pencil. So this pack of 30 is a much better deal. It does cost more than the pack of 12, but you're getting almost 3 times as much, or 2.5 times as much as this. Okay, so the unit rate here is 0.27, and the unit rate here is 0.40. When you divided this, you might have gotten 0.2656, and it went on and on. But we don't have that many decimal places in money. We actually only have 2 decimal places. We have to look at this next number, though. Since it's 5 or more, we're going to round up. So we go up a penny to 0.27. Okay, and then which one is the better buy? The 30 pack of 30 is the better deal because each pencil costs 27 cents, which is better than each pencil costing 40 cents. So see if your parents have ever done that before, whether it's like, a package of beef or something and it has pounds, or, I use it. My personal example is I use it with diapers. I try to figure out, okay, if I'm going to buy these diapers, which one is the cheapest per item? Okay, so you might have done this or seen something like this at a store when you were doing back to school supplies. So there's a lot of examples. Ask someone like an adult and see if they've ever thought about what the price per item or per pound would be. Okay, and then we are actually going to come to a close here. I'm going to have you pause and write this down. Usually the summary you're going to do in your own words. I'm going to get you started though for this very first one. So the summary answers our essential question. The essential question was, how is finding an associated rate or unit rate helpful when making comparisons between quantities? Okay, so the summary answers the essential question. So anytime you see that summary and you go, what are we supposed to do there? You're answering the essential question from the beginning. Okay, and that's it. So I'm just going to stop the video here. You can pause it so that you can still see the summary. And that is your very first lesson.